Click the bell icon to get latest videos from Ekeeda.
Hello friends. Previously we have discussed the CYK algorithm, which is a form of dynamic programming in which we were trying to find whether the given string belonged to the language generated by some grammar, which was context free. Now, let us discuss some examples in which under the given grammar, we have to parse the given string using CYK algorithm. We know that the complexity of CYK algorithm is order of W cube, where W is the length of the string. Before using CYK algorithm, we know that the grammar has to be converted into CNF, that is Chomsky normal form. Let us check whether the given grammar is in Chomsky normal form or not. There are four non-terminals in the given grammar: S, A, B and C. S is producing AB or S is producing BC, in which AB and BC both are non-terminal. Hence we can say that the production of S is in Chomsky normal form. Similarly, A produces BA or A produces A. In one case it is both non-terminal, which is in CNF. In the second case it is just one terminal, which is also CNF. Similarly, B is producing CC, which are both non-terminals, or B is producing small b, which is a terminal. So this is also a case of Chomsky normal form. Last production, C produces AB or C produces A. One is a case of both non-terminals, one is a case of only one terminal. Again, this is in Chomsky normal. Again, this is in Chomsky normal form. So we can say that it is verified that the given grammar is in Chomsky normal form. Over here in the question, the string given is BAABA. We have to check whether BAABA could be produced by using this grammar or not. For applying CYK algorithm, we have to use a table, which is a part of the dynamic programming algorithm. Over here in this table, you can see that I have a number of rows to represent the string. Similarly, a number of columns to represent a string. I have written the string BAABA over here and the reverse of that over here. That means from here you can say that BAABA. I have given indexes to every letter in the string. The string is B A A B A. We are indexing them using 1, 2, 3, 4 and 5. So there are 5 symbols in the given string. Hence we come up with a table of 5 cross 5 like this. What does this table represent? This table will contain the LHS of a production which will be producing a string which starts from one of the characters from this list to one of the characters in this list. Now, which production will be used? That is dependent on the grammar. Let us see how the algorithm works. In the algorithm, we start with length is equal to 1. We try to produce 1 letter substrings of the given string. Then we try to produce 2 letter substrings of the given string. Then 3 letter substrings and so on. Over here, we will end with a string of length 5. Let us say we are starting with length 1. I am rewriting the string on this sheet so that we can cross-refer to that. Let us say we are generating substrings of length 1. Over here, 1 to 1 it would be B, 2 to 2 it would be A, 3 to 3 it would be A, 4 to 4 it would be B, and 5 to 5 it would be A. How can we generate B? Let us go to the grammar. In the grammar, B is produced by using the production. Capital B produces small b. So we can say that the production is having B on the left hand side. The right hand side was small b and the left hand side is capital B. We can put this information into the main table for dynamic programming. This is the string starting from position 1, ending at position 1. It will go to this block as the production B. Similarly, for the second case, we know that from 2 to 2 it is A. So the RHS of the production would be A. In the grammar, if you check, A is produced by, using the production, capital A produces small a. Similarly, using the production, capital C produces small a. So we will have two non-terminal, A and C, producing small a. You can say that the RHS would be A or C. For dynamic programming, we will put this information into the table. Similarly, for the third case, that is from position 3 to 3, again the LHS is A, so we can follow the same path. RHS is A, the LHS would be the same, A followed by C. Let us put this information into the table. From position 4 to position 4, let us see the string. Over here it is B. We have already solved for B. Let us copy that. LHS is B. The RHS which can generate B is capital B. Let us put this information into the dynamic programming table. From position 4 to position 4, over here we'll have to put B. Let us check the last one of length 1 at position 5. It is the alphabet A. RHS would be A. From previous rows, we understand that A is produced by either A or C. So the LHS would be A or C. Let us copy this information to dynamic programming table. We understand that now we have completed the table for all strings of length 1. Now let us proceed to length 2. What would be the substrings of length 2? Position 1 to 2, 2 to 3, 3 to 4 and 4 to 5. Substring length is 2. The positions are 1 to 2, 2 to 3, 3 to 4 and 4 to 5. But how do we generate a string from 1 to 2? There is only one way, that is substring 1 to 1 concatenated with substring 2 to 2. It is basically the concatenation of alphabet at 1 1 and alphabet at 2 2, which forms the entire substring 1 to 2. Similarly, let us write the rest. This one would be 2 2 followed by 3 3. Next one would be 3 3 followed by 4 4. Last one would be 4 4 followed by 5 5. Now comes the role of dynamic programming. We have already completed the dynamic programming table for length 1. Now we use that particular table to find out new productions which has to be generated. 1 1. Over 1 1 we see that the symbol is B. In case of 2 2, the symbol is A or C. If we apply concatenation, this must be either BA or BC. Now let us go to the table and write down these right hand side of productions. This was 1 followed by 2. The RHS we got is BA or BC. Let us go to the grammar and find out which are the production producing either BA or BC. We see that BA is produced by A, BC is produced by S. Let us write these information to our tables. The LHS should be A or S. In our table, it would be row 1, column 2 appended by A or S. Now let us see length 2, the next string, that is 2 to 3. The split possible is 2 2 followed by 3 3. Let us see what is generating 2 2 and 3 3 from the dynamic programming table. 2 2 is produced by using A and C. 3 3 is also produced using A and C. On concatenation, what we would get is AA, AC, CA or CC. Let us write these right hand side of productions into a table. Let us see which of the grammar symbols are producing these productions. AA is not produced using any production. AC is also not used. AA is not produced by any production. Similarly, AC is also not produced using any production. CA is also not there in the production. But we have CC produced using B. So let us write B. AA is not produced. AC is not produced. CA is not produced. But CC is produced using B. And hence 2 3 in the table would be B. Over here in the table, row 2 column 3 would be B. Now let us move on to the next string. The next string is 3 4. The only split possible is 3 3 followed by 4 4. Let us see what are 3 3 and 4 4 being produced by from the table. 3 3 is produced by A and C. 4 4 is produced by B. Let us write down these information. 3 3 by AC and 4 4 by B. The concatenation should be AB or CB. Now let us check the productions to find out which are producing either AB or CB. You can see that S and C are producing AB, but CB is not produced using any production. So we will have only two LHS. One would be S, the other would be C. Let us fill the information. The RHS were AB and CB. LHSs S and C. Let us fill this information to our table. The string was 3 4. Over here it would be third row, fourth column. We will have S or C. Let us see the next string now. The string is 4 5. It would be concatenation of 4 4 followed by 5 5. Let us see the productions for 4 4 and 5 5. 4 4 is produced using B. 5 5 is produced using 4 4 is produced using B. 5 5 is produced using A or C. Let us write these information. Let us do the concatenation. Let us do the concatenation. Concatenated with A or C give us BA or BC. We have already solved this. For 1 to 2, we reuse it. BA is produced using A. BC is produced using S. Hence, we will have RHS, BA or BC. LHS would be A or S. Let us write this information. In the dynamic programming table, it would be row 4, column 5, A or S. This is row 4, column 5. Over here, you can see that we have found the productions for all substrings of length 2. Now, let us find productions which are producing strings of length 3. Let us see substrings of length 3. It would be 1 to 3, 2 to 4, and 3 to 5. Unlike the previous case, now there is only not one case for concatenation, there could be multiple. A length from 1 to 3 could be concatenation of 1 1 followed by 2 3, or it could be a concatenation of 1 2 followed by 3 3. That means it could be two ways: symbol 1 2 concatenated with 3, or symbol 1 concatenated with 2 3. Let us write the splits. We already know that 1 1 is B. From here we need to find 2 3. Second row, third column from the table, it is B, hence the concatenation must be BB. Let us find 1 2. First row, second column, it is A or S. From here we know that 3 3 is already A or C. The concatenation must be AA, AC, SA and SC. Let us go to the grammar and find out which of them are produced by the grammar. First, let us write down the RHS. They were AA, AC and SC. And other than that, we had one more case which produces BB. We see that BB is not produced by using any symbol. None of the RHS are produced by any of the LHS in our grammar. That is, neither AA nor BB nor AS nor SA and nor SC. And hence we can say that 1 3 is a substring of the string which is not produced by any symbol. We insert this using a null. This is first row, third column, we append a null there. Let us see the next string 2 4. Let us see the next string 2 4. The splits possible are 2 2 followed by 3 4, or 2 3 followed by 4 4. Let us see which are the productions producing them. 2 2 is produced by A or C. Next portion is 3 4. Let us check 3 4. We see that 3 4 is produced using S or C. Now let us write the concatenations. AS, AC, CS and CC. Let us see which are producing these. Out of the concatenations, you would see that only CC is the one which is produced using our grammar by the symbol B. The others are not produced using our grammar. Now let us see the next one. That is 2 4 could also be produced using 2 3 followed by 4 4. What is 2 3? 2 3 is symbol B. 4 4 we have already calculated. It is B, and hence the concatenation would be BB. But you would see that this particular string is not generated using any of our non-terminal. Let us write down this information into our table. The RHS for string 2 4 were AS, AC, CS, CC and BB. Out of which we have only one string CC possible using LHS B. Let us write this information to our table. That is 2 4 is generated using B. This was 2. This was row number 2. On column 4 we will write B. Next substring was 3 5. We can split 3 5 into 3 3 followed by 4 5, or 3 4 followed by 5 5. 3 3 is generated using A or C. 4 5 is generated using A or S. Hence the concatenations should be AA, AS, CA and CS. If you check the grammar, you will find that none of these strings are generated by any of our production. Let us move on to the next case. 3 4. 3 4 is generated using either S or C. 5 5 is generated using either A or C. The concatenation would generate SA, SC, CA, CC. Out of these substrings, you will find that the only substring which is generated by our grammar is CC using symbol B. Let us write this information to our table. I am writing only those RHS which are at least generated by our grammar. In this case, it would be CC, which is generated using B. In the table, they will write 3 to 5 is generated by B. This is row 3, column 5, P. With this, we have written all productions of length 3. Now let us go to length 4. Let us see substrings of length 4. The substrings would be 1 to 4, 2 to 5. First, let us solve 1 to 4. How can we split the string from 1 to 4? It could be 1 1 followed by 2 4, or 1 2 followed by 3 4, or 1 3 followed by 4 4. Now let us refer to our table and find out which are the productions producing these substrings. 1 1 is produced using B. 2 4 is also produced using B. Hence the concatenation would be BB. 1 2 is produced using A or S. 3 4 is produced using S or C. Let us find the concatenations. It would be AS, AC, SS, and SC. Now let us find the third one, 1 3 and 4 4. You will see that 1 3 is not produced using any production, hence we have a null. 4 4 is produced using B. 1 3 would be null, 4 4 would be B. Concatenation of any string with a null would be null. Out of these RHS generated, you will find that none of them is produced using any of the grammar symbol in the given grammar, and hence 1 4 must be set to null. Now let us see the next substring 2 5. The splits possible for 2 5 are 2 2 followed by 3 5, or 2 3 followed by 4 5, or 2 4 followed by 5 5. From the table you will see that 2 2 is generated by A or C, 3 5 is generated by B, hence the concatenation must be AB or CB. Let us check 2 3. 2 3 is generated using B. Let us check 4 5. 4 5 is generated using A or S. Hence the concatenation should be BA or BS. Let us see the next case. 2 4. 2 4 is generated using B. Let us check 5 5. 5 5 is generated using A or C. Let us write down the concatenations BA or BC. Now let us find out which of them are generated by our grammar. AB is generated using either S or C. CB is not generated by our grammar. BA is generated by A. BS is not generated by our grammar. Again, BA is generated by A. BC is generated by S. Now, let us write down this information to a table. The possible RHS were AB and BC. The respective LHS were S, A and C. Let us write this information to our table. 25 is generated by SAC, so you will write second row, fifth column. 25 is generated using S, C and A, so we will write that into second row, fifth column. S, A and C. 14 was not generated. We embed that information also. Now let us try to construct the entire string 1 to 5. Let us start with string length 5. The only string possible is 1 to 5. The possible splits are 1 1 to 2 5, 1 2 to 3 5, 1 3 to 4 5, or 1 4 to 5 5. One 1 is generated by B. 2 5 is generated using S, A and C. Let us use this information. This would give us the concatenation BS, BA and BC. Let us check 1 2 and 3 5. 1 2 is A or S, 3 5 is B. The concatenation should be AB or SB. Let us check 1 3 and 4 5. 1 3 is null, 4 5 is A or S. This would eventually give us null. Let us check now 1 4 and 5 5. 1 4 is null, 5 5 is A or C, which would eventually give us null. Now, from the produced RHS, let us find which all are produced by our grammar. BS is not produced by our grammar. A produces BA. S produces BC. S and C both produces AB. SB is not produced by our grammar. And the rest are null. Let us write these information into our table. After completing the table, we see that S comes at the position 1 to 5. That means S can generate the string 1 to 5, which is the entire string, and hence we can say that the string is generated by a language. If we have to check which are the substrings of the given string which are generated by the grammar, we can check that where are start symbol S generated. You will see that 1 2 has S. Cell 1 2 contains start symbol S, and hence the string 1 2 must be generated by grammar. String 1 2 is BA. Similarly, 2 5 is containing S, hence substring 2 5 must be generated by a grammar. It is AABA because we start from position 2 and end at 5. Similarly, cell 2 5 contains S. Over here, the substring from position 2 5 is A, B, A, and hence a grammar must be generating the substring AABA. There is a case. Similarly, 3 4 contains S, and hence our grammar must be generating the substring from position 3 to position 4. It is AB. Cell 4-5 contains S. Hence, the substring BA must be generated by our grammar. With this example, we have solved a problem in which we are applying CYK algorithm to find out whether the given string belongs to the language generated by the given grammar or not. In the next video, we will be solving one more question on CYK algorithm. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.